How's it going, everybody? My name is Josh. I was a computer science examiner, head of computer science in UK-based schools, and now I run a tutoring business where I've helped thousands of students to get better grades in computer science-related courses. Now, this series of lessons is all to do with giving you all of the main points that you need to know for all of the different data structures that you have to know for all A-level specifications. Now, I was having a look through all of the spec points. These are Cambridge International at the top there, OCR in the middle, and then AQA at the bottom. Every single one of you has to know about hash tables. And I just thought I'd make a quick lesson on that now and just going through the main points so that you are understanding what you need to do and what you need to write down for any hashing potential questions. So first one, what is a hash table? Key things that I need to see is, when using my examiner knowledge, is it's an abstract data type, which means that we abstract the idea of what a hash table is, because there's not like a pre-written data structure that we would use in our programming language of choice. We have to use other data structures to create it. And what it does is it allows us to instantly be able to put data in there and also to be able to search for them. It means that we don't have to be using lots of different things like binary searches and sorts, which can take a large amount of time for these to find the particular value we're looking for, or even place a value in there. To add a value into a hash table, because it does specifically say how do we add a value into the hash table, it also says deleting, which we'll come on to later. A hashing function will generate a value from the data. That's how, if you're looking for something, it can instantly find you where it is. So one of the most common ones is it use what's called a hash function to do this. And the example I've given here, let's say that you've got a hash table which has got 100 items in there. And what it's going to do is we've got the data 154 that we need to store into into our hash table. So we do 154. Mod it with the number of items we've got in our table, or the number of spaces available, which is 100, and that gives us 54 because it returns the remainder. It's then stored in the 54th position. So it's just a way of instantly being able to find and place values in our hash table. Other key points. What happens if two values generate the same data location? So that is possible. Let's say that we got 154. And that gives us the 54th position. And let's say that we got 654. Even though they're different data, they generate the same the same position that it needs to be stored in. So this is what I would say on this one. This is a collision. A collision is a problem because what it can actually cause is something called clustering, where you've got lots of data all together, and that can be an issue when you're trying to search for it. So ways around this is we can implement what's called a skip, which is where the first time it's going to place it in the next value, the next time it can do it in 3 values, 5 values, and it just keeps getting it further and further and further, so you don't have that clustering problem. Advantages and disadvantages of hash tables. This is specifically for the AQA specification, but it's still good to know for the other ones. Hash tables allow you to instantly search and place values, so add values in there, so you don't have to waste time in searching using binary searches or sorting the values to start with. Collisions. With collisions, that we've kind of already mentioned that they can lead to clustering, which is where you've got lots and lots of data in the same space, and that can also slow search time down dramatically. This is also apparent when you've got quite a lot of data in the hash table already, which is why they quite often say to have a load factor, which is how much data is in there, between 50 and 70%. Just so that you can see how a searching algorithm works, one of the things that we need to make sure that we do is when we delete a value, we have to make sure that we put a placeholder in that place. The reason for this is because how the search algorithm works, and let's say that we've implemented a lot of collisions, and we've had to skip a lot of values. Well, what we have to do is we put a placeholder in it when we delete something, because as you can see, the search algorithm will stop, right, if it gets to a place where there is an empty space. Now, let's say that we delete a value and we do not put a placeholder in there, but then we put another value after that in the skip algorithm. It's never going to find that value, And that can be a huge problem because even though the value's in there, it's never found using our search algorithm. And that's a big one. So if it ever asks you about what happens when you delete a value from the hash table, you need to say that a placeholder is put there so that when you search, that then when it tries to goes onto the next value, it still will be able to find it in the search algorithm. Now, thought it'd be a good idea just to show you about placing some values in here. We've got 5 data locations here. So we've got 0, 1, 2, 3, and 4. And then we've got some values that we're going to put in there. And you're going to see what happens when we've got different things in there. So if we mod this with the number of values that we've got there, so we're going to mod it with 5. So that's just going to return the remainder. You divide it and get the remainder. So that's going to give us 4. So we're going to store that in location 4, which is there. We mod this one, which is going to give us 2, because obviously 25 and then the remainder there. So we're going to store that in 27. This one here is going to give us 2 as well. Now, we're going to implement a skip in there. So actually, I'll put that one on the same line as well. So we're going to implement a skip in there. So what we'll do is we're just going to pop that in this position here. Okay, so we're going to put 17 there. And we're going to, obviously that's going to stay there. 44. It's going to give us a mod of 4. So it's going to go 27, 17, 14. Again, we're going to have to skip. We've got 44 in there. Now, in a slightly larger hash table, what we might have to do is implement the skip so that they're a bit further so that you don't have lots of clustering. But in this case, we don't have any, that's not going to give us any advantage because the hash table is so small. Final little part, which I thought that we could have a little look at, is how do we actually do this in a programming language? Like, how do we add a value? How do we create a hash table? Now, with a hash table and all of the values in it, we use a dictionary. A dictionary is, so going off that basis of that, it's an abstract data type. Abstract data type means that it's not, we only focus on the things which are really, really important. And we have to abstract the idea of it because there's not just like some different brackets that you can put in there, which is going to give you a hash table. So we have to use a dictionary, which we put the values in there. So I've just put some dummy values in there at the start. It's going to give us a score. So the person enters in their score. We generate the position. Let's say that this is going to allow for 100 values. So I mod it with 100. And then what that does is that generates me a position and then the score. And then what it's going to do is then I'm just going to output it there. Okay. So that's how you add a value into a hash table. This is how you just create it using a dictionary. This is using a hashing function there if you need to write the code for that. And then this is how you output it. So it might be a good idea. Just write that, see it working, see how it works, or put it in your own programming language of choice.